Good morning, students. Today we are going to discuss the problems on the topic that we have discussed earlier, resistance in series and parallel combination. Our first problem is show how would you connect three resistors each of 6 ohm so that the combination has a resistance of first we have to find for 9 ohm and second one is for 2 ohm. Let's discuss one by one. First one, we have to connect two of the resistors in series combination, in parallel combination, each of 6 ohm and 6 ohm. For this parallel combination, our output or equivalent resistance will be equals to 1 by 6 plus 1 by 6, it will be equals to 2 by 6 and it will be equals to 3, means this is the value of rp for parallel combination, which implies rp is equals to 3 ohm. rp will be equals to 3 ohm, and if we connect a resistor 6 ohm in parallel, then 3 ohm and 6 ohm both were in series, then the equivalent resistance will be equals to 9 ohm. Okay, for the second case, if we connect all the three resistors in parallel, if we connect all the three resistors in parallel, then 6 ohm 6 ohm and 6 ohm, then the equivalent resistance 1 by R equivalent will be equals to 1 by 6 plus 1 by 6 plus 1 by 6, and it will be equals to 3 by 6 and it will be equals to 1 by 2. So the R equivalent will be 2 ohm. So to get a resistance of 2 ohm from 6 ohm resistors, we have to connect all the three resistors in parallel, and to get a resistance of 9 ohm, we have to connect two of the 6 ohm resistors in parallel and 1 ohm resistor in series with them. Okay, let's discuss the second question. A piece of wire of resistance R, a wire, suppose this is our wire having a resistance R, is cut into 5 equal pieces, is cut into 5 equal pieces, 1 2 3 4 and 5, and then they are connected in parallel. Each wire is connected in parallel. If the equivalent resistance is R prime, for this combination we have equivalent resistance R prime, then find out the ratio R divided by R prime, means we have to find out the ratio for the initial resistance to the final resistance. If this wire is cut into 5 equal pieces, then the resistance will also be divided in 5 parts. So the resistance of each part will be equals to R by 5, R by 5, R by 5, R by 5 and R by 5. So 1 by R prime will be equals to 1 by R by 5, means 5 is there, plus 5 by R plus 5 by R plus 5 by R plus 5 by R. So from there 1 by R prime is equals to 25 by R. Okay, we have to find the ratio R by R prime. Let it be cross multiplied, then we have R over R prime will be equals to 25 ohm, not the ohm. R by R prime will be equals to 25. Okay, let's discuss the third question. Our third question is, we have given a figure in which four resistors are connected in such a manner that 1 and 2 ohm resistors are in series, and this combination of two resistors is parallel with the 3 ohm resistor. First we will find out the equivalent resistance here. So equivalent resistance will be equals to this 1 ohm and 2 ohm are in series, so these two will make a resistance of 3 ohm. So for, let me point these terminals A and B. So the resistance between A and B, first we find the resistance between A and B, and it will be equals to 1 by R AB is equals to 1 by 3 plus 1 by 3, it will be equals to 2 by 3, and from there RAB will be equals to 3 by 2, and it will be equals to 1 by 1.5 ohm, and the total resistance, equivalent resistance will be this 1.5 ohm and this RAB, both were in series, so 1.5 ohm plus 1.5, it will be equals to 3 ohm, it will be equals to 3 ohm. Now we will find the total current flowing in the circuit. As given, potential is 6 volts. According to Ohm's law, V is equals to I times R, and I will be equals to V by R. The value of V is 6 and R is equals to 3. So a current of 2 ampere will flow in the circuit. So a current of 2 ampere flows in the circuit. This 2 ampere current will flow in this 1.5 ohm, and it will be divided into two equal parts of 1 ampere and 1 ampere, because both of the branches, upper branch and lower branch, have the same resistance, that is in this branch 3 ohm resistance, and here also we have the 3 ohm resistance. So 1 ampere current will flow in this branch and 1 ampere will flow in this branch. Okay, so we have to find the potential drop across 2 ohm resistor using the Ohm's law. Using Ohm's law, potential drop across 2 ohm resistor will be equals to I times resistance, and I, the value of I is 1 and the value of resistance is 2. So we have a potential difference of 2 volt across the 2 ohm resistance. Okay. Our next question is, find out the equivalent resistance between the terminals A and B. We have to find the resistance between the terminals A and B. Here we have no battery, so let's consider that current is flowing in this direction. If current will enter in this branch from this terminals, say C, and this one is D, then it will be divided into two parts, and when the current is divided, then the circuit is in parallel. From this CED, the branch CED is a single branch and no current division takes place. So this 1 ohm resistance and this 1 ohm resistance will be in series. So the branch, the resistance of branch CED will be 1 plus 1, it will be equals to 2 ohm. This 2 ohm resistance will be parallel this with this 2 ohm resistance. So this circuit can be implemented as 1 2 ohm resistance here for this branch and 1 2 ohm resistance for this branch. Both of the resistors are in parallel, so R equivalent, 1 by R equivalent will be equals to 1 by 2 plus 1 by 2, or 1 by R equivalent will be equals to 2 by 2, which implies R equivalent will be equals to 1 ohm. So the resistance between the terminals A and B will be 1 ohm. Okay, similarly we have to find the resistance between the terminals A and B. Here also let's find one by one. Suppose we have the terminal A and B connected to wires in this manner. When the current enters at terminal A, it will be divided in equal parts, sorry, three parts, and the current flowing in branch ACB will flow along a single path, and the current flowing in branch ADB will flow in a single branch. So 3 ohm resistor and 2 ohm resistor are parallel in series, and these 3 ohm resistance and 2 ohm resistance are also in series. So the resistance for ACB will be equals to 3 plus 2, it will be equals to 5 ohm, and the resistance for ADB ADB it will be again equals to 3 plus 2, 5 ohm. So this circuit can be drawn as here we have terminal A and this is B. This is 5 ohm, this is again 5 ohm, and this is 1 ohm. All the resistances are now in parallel combination. So the R equivalent will be equals to 1 by 5 plus 1 by 5 plus 1 by 1, or 1 by R equivalent will be equals to 5 1 plus 1 plus 5, it will be equals to 7 by 5, or R equivalent will be equals to 5 by 7 ohm. R equivalent will be equals to 5 by 7 ohm. Okay, our next question is this one. Here we have to again find out the equivalent resistance, or the resistance between the terminals A and B. If the current enters along this path, then it will be again divided into two parts. So this branch and this branch will again be in parallel. So first we have to find the resistance for branch CED. CED, it will be equals to 3 plus 3, it will be equals to 6 ohm, and this 6 ohm resistance, this circuit can be drawn as now. This circuit is reduced to this one. This is 3 ohm, this is 3 ohm, this one 3 ohm, and for these two we have the 6 ohm. This is our C terminal, D terminal, and this is our A, and this is B. Now this 6 ohm resistor and this 3 ohm resistor is in parallel. So the resistance for C and D branch, it will be equals to 1 by R CD is equals to 1 by 6 plus 1 by 3. 6 will be LCM. So we have 1 plus 2. It will be equals to 3 by 6, and it will be equals to 1 by 2. It means 1 by RCD is equals to 1 by 2, or RCD is equals to 2 ohm. The resistance of this branch or this whole circuit is 2 ohm. So now our circuit is reduced to this is our A terminal, this one is our B terminal, this is C, and this one is D. This is 2 ohm, 3 ohm, and 3 ohm. Now all the three resistors are in series. So the R equivalent will be equals to 3 plus 2 plus 3, and the R equivalent will be 3 and 3 6 plus 2, it will be 8 ohm. Okay, this will be the final resistance of the circuit given. Okay, so dear students, this is all for today. We will meet in the next lecture. Thank you. Have a nice day.